Okay. Yes. So welcome everyone to my talk about multi-view embedding. To quickly introduce myself, my name is Fré. I've been working with Flutter for apparently as long as Flutter Belgium has existed as well, since 2018. I'm a freelancer and I offer consulting, coaching and development services through my company Skystone Apps. And my current role is being lead developer at Robaus. Now, Robaus is a company that provides a cloud-based enterprise resource planning system for the construction and installation sector. And they mainly have three customer-facing apps, which are two mobile apps written in Flutter and a web application. Now, the web application is the biggest part of the platform, and generally speaking, the features are developed on web first and then find their way into our apps. But sometimes it just goes the other way around. We develop a certain feature in one of our apps, it gets ported to the other one, and of course our web users will want to use that feature as well. So we start looking into how can we provide that feature to our web users without having to write the feature all over again. And since Flutter offers support for web as well, a Flutter web application is the way to go. But how do we offer it? So there's basically three ways to do this. You could simply create a separate app, a separate tab, and then go to a different Flutter web application that has those features in them. And this is by far the simplest way, but obviously there's not a lot of interaction with your original application. This would cause a very disruptive user experience because you leave the app, you don't really know where you're at, and you might not even come back to the original host application. If we do want to integrate it a little bit, we can look at iframes. So those provide somewhat of an integration. But who here likes to use iframes? Oh, a few people. Okay. Well, generally speaking, if you've worked with iframes before, they do come with complex communication. They also are very sandboxed and might cause some security hurdles to overcome. And they can result in a bit of performance overhead since it's loading a whole separate browser context in there as well. So luckily, there's a third way that we can provide our features to our web users. And since like most of you probably read the title of this talk, it's embedding those features. So if we do this right, we get a complete seamless integration with the host platform. And it's just the best experience we can offer. But it does come with some initial setup. And I'm going to try to explain to you how we can actually do this. Now, first let me go into the history of embedding Flutter web apps a bit. So when Flutter 2.0 came out with support for web apps, it was only possible to place your Flutter web application inside the body tag of an HTML page. Now, there has been a process of multiple steps to enable this, and they were defined within this document, which I think has an awesome title. It's called Astral Projections for Enabling Out-of-Body Experiences. So just wanted to share that one here. But eventually in Flutter 3.7, with a minor API change in 3.10, we were able to actually use different elements than the body element to render our Flutter apps in. And since one is just a special case of many, since last year, it's also possible to create multiple views for our embedded Flutter web applications. So what actually is a Flutter web application? How does it look like? I've made a simple example here. We have our Belgian Bonanza game, where we can vote what our favorite Belgian snack or delight actually is. So I'll just pick a few. Let's say we'll add fries in there. Let's maybe have chocolate. Let's have beer. Some people are having a beer. Well, we'll get to that point. I'm not going to do waffles. I'm not into waffles today. But who likes fries? Okay, there must be like something like this amount of people. Anybody likes chocolate? A little bit less. Okay. All right. And who likes beer? Okay. There we go. Okay. Now, what we see here, it's a web page that is embedding one Flutter application with multiple views that also access the same memory. So you can see that on every view, the total count is also displayed, while it also has its own state. So how can we build something like this? Let's go into how we set up embedding, but first, let's start by looking at a normal Flutter web app. How does it actually work? When we run the build command, we'll end up with all these files here. This is just an example from the typical counter app. Some of them are already present in the web directory. Others are generated on the spot. So let's initially start looking at the index file. This is what we open in the browser. And most of this here is related to our web page. Only a small part of this is actually our Flutter app. So let's see what's in this bootstrap file. We see a lot of generated code there, but we can mainly split it up into three parts. First part is about the Flutter loader. The second part will provide us with a certain build configuration, which will also reference our entry point. This is the main.dart file, or at least its JavaScript equivalent. And last but not least, the loader is executed and the engine is initialized and the app starts running. So this is what happens in the bootstrap of a Flutter web app. So very strictly speaking, we would only need a bootstrap file, our entry point, and that one will probably call some assets as well. So what if we just copy all of those into a complete different web application? We're almost there. We just need to make a few adjustments. So as you can see, we provide a certain element with an identifier. In this case, it's this one right here, or at least this one right here. This is going to be the div that's going to contain our Flutter application. Preferably, we're going to give it some dimensions as well. Other than that, we're just calling the script of our bootstrap file, and that's the only thing that we have to change in our web in our index.html file. We have to make a slight adjustment in the generated bootstrap file, where we actually provide some extra configuration, where we can actually provide it with the specific host element in which it should run. Now, obviously, we don't want to make a manual change every time we run a new Flutter web build, so we can actually customize this bootstrap file as well. So by adding the bootstrap file into our web directory, we can start making changes to it. So we don't need to have this whole generated piece. We can simply use two small placeholders and then take complete control over the configuration for our loader. So there we have it. So that's all we need to do to embed a single view Flutter web application. But I think most of you came for multi-view embedding. So let's see what other steps we need to do. This is going to be quite some code. There's going to be 5 steps that we need to go through. The first one is already done, customizing the bootstrap file. So let's look what else we can change in that bootstrap file. Let's have a look at onEntryPoint loaded callback. This is a very basic implementation. It's basically what the default implementation does as well. It initializes the engine and then runs the app. If we want to have a multi-view application, we just need to provide it with an extra flag, multi-view enabled, and we have to keep a reference to the app object that is returned from this run app. We're going to need this later. So if we then just try to run it, we run into an issue where basically we cannot use run app. And to explain this, we're going to have a look at how widgets binding work in a normal Flutter app. So if we run a normal Flutter web application, the widgets binding will provide us with an implicit Flutter view. This is an area in which our widgets will be rendered. And run app will typically take a widget and put it in there. But since we're working with multi-view application, there isn't going to be any implicit Flutter view, so it's not going to find any view to render it on. Therefore, we have to use run widget. Run widget allows us to actually bind specific widgets to specific Flutter views. If you're going to try this out, I would recommend going to the docs and start playing with the example widget that they provide. It's called multi-view app. It basically listens to the widget binding and will then, for every Flutter view that it finds, it will connect it to the right widget. This will happen through the didChangeMetrics callback, which is called every time you add a view or you remove a view, or even when you change the dimensions of your browser window. And if we use it, this is how our main.dart function will look like. So slightly different, slightly more complex than just run app, which are widget, but it's still quite understandable. Good news, that was already step 3. 2 more steps to go. Because if we're going to run this, we're just going to get a blank page. Nothing's going to happen, because we haven't added a view yet. So going back to JavaScript, on the reference of the app object that we had earlier, we can then tell it to add a view for a specific host element. And that way, it's also going to provide a view ID, or return a view ID. And we can use that later if we want to remove that view again. Then it will cleanly dispose the whole widget tree that's underneath there. So there we have it. Instead of one counter, we have multiple counters. But I think in a real use case, you'll probably don't want to have multiple instances of the same thing. And that's where the last step comes in, and that is to provide some initial data. So with the addView function, you can also provide any type of data to start with. In this example, I just give an object that has a color code, and as you can see, it will be used to change the color scheme for each counter or for each view. This can actually be anything, and the way we're gonna get that initial data in our widgets tree could be from anywhere in the context. So in the widget tree. So we're gonna use the context to ask which view am I running on at the moment. Then we can, with that view ID, we can ask what was the initial data passed in for this specific view. And last but not least, we can easily cast this to an extension type. This uses JS interop, which I'm not going to address within the talk. It would be a little bit too much, but it allows for easy access to our properties in Dart. And so this is still a very simple example, just changing a few colors, having different counters. But we can take this a lot further and provide completely different widgets. So in this example, we have one Flutter app that will actually run basically completely different apps on every view. So we have a counter, to-do app, or the Wondrous app that you might have all seen as a demo application. Okay, so let's sum this up. These were the 5 steps that we need to do. So I'm happy that everyone is still still listening. But initially, we need to customize the Bootstrap script. We need to pass in multi-view enabled to the engine. We need to use run widget instead of run app. And then we can start adding multiple views. And preferably, we'll do this with some initial data. So this is all we need to do to have a multi-view embedded app. Now, there is one thing that I didn't really mention here. I assumed in these examples that both our Flutter code and our HTML code are hosted on the same domain at the exact same location. While in real life, it's probably going to look a little bit more like this, running on a different path or maybe on a completely different domain. And this is definitely going to happen when you're developing. So your Flutter app will run on a different port on localhost. Your web application will be somewhere else. Luckily, we can also provide this in our configuration. We just need to add these URLs in 2 different places. So we need to add an entry point base URL so that it knows where it should fetch the main.dart file. And then for our assets, we have to do the same, if we're hosting the assets on the same place at least. These could be complete URLs, but it could also just be a path if it's all running on the same domain. And one thing I really want to mention, because I kind of feel ashamed how many times I ran into this and how much time I lost. But there is an inconsistent casing in the word entry point. And this happened to me more than once. So watch out for this. I submitted a bug for that. Let's hope it's get resolved in a later version, but we'll see. Okay, now I want to go back to the demo application because you know how live demos goes. They just never go perfectly. So I don't know, did anybody see what was wrong in the demo app? Oh, that's good. So let's have a look. Does anybody see it right now? Yeah, it's the double colons that we have there. So let's see if we can fix this, because I won't get to it if I don't do it right now. And we have time anyway, right? So yeah, let's quickly see how this works, because I developed this so long ago. It must have been like yesterday or something. So I don't know where those widgets are, so let's go have a look. We use the widget inspector on this. Let's click here. Oh yeah, okay, there it is. Perfect. Okay, there we have our widget tree again. Yeah, let's just change this real quick. Hit save, and there we go. Okay. Looks a lot better, right? And we didn't lose any of our votes. We still know exactly what is the most popular delight at the moment. So what I wanted to show with this is even in embedded application, we can use our debugging tools and still have stateful hot reload, which is the new thing that they just added. Yeah, for web. So now there are a few things that we need to do for this, but don't worry, I've written most of them here. Let's see, there's my demo app. Okay. So hot reload and debugging. This is the fairly complex run command that I used for this. And I have to make one note. This is currently not yet unstable, but the fix has is already available on the master channel to use this for embedded applications. So we'll see this very soon. So we're using this experimental flag that you may have not seen with the last version of Flutter to enable hot reload for web. And because we're running on 2 different domains, and our local host 8080, our host application, is fetching our Flutter code from somewhere else, we can provide these web header parameters to add all the necessary course configurations. This will, because everyone who has run into course issues, yeah, so this will help you definitely. And another caveat is that this currently only works when you're targeting Chrome, or at least in debug mode. So if you spin up a Flutter web application in debug mode, there's going to be a Chrome instance that is spawned. You need to use that one specifically. But since we're using an embedded web application, we can easily use the web launch URL and point it to our host application, so we can just still have it in one click. And as I mentioned before, this allows you to use the debugging tools, but also allows you to set breakpoints and everything like that. So this will really speed up development. I'm very happy because I think a few weeks ago, this would have been a whole different process with copying and symlinks to make it work as fast as possible, but this will be enabled soon on the stable channel. Okay, then there's only one topic I want to go into, and that is reducing load times. Because for web applications, we always try to keep the file sizes very low to have a smooth experience, definitely at startup. But if we look into this example that contains actually 3 pretty simple apps, the Wondrous app might be a little bit more complex, but it's mostly very heavy on assets, not on code. This will already result in an entry point file that is over 4 megabytes, which is quite a lot. Luckily, in Dart, we can apply lazy loading on web by using the deferred as keyword on our imports. What this will do is it will implicitly provide a load library function that we have to call first before we want to call anything. And when we call load library, it will then download the code for that specific import. The compiler will be smart enough to split it up into multiple files to make sure that you don't need to download too many files and that they stay as small as possible. I suggest using this with something like a future builder, or you could use any mechanism behind it actually. Now if we apply those to the example that we have and we run our build again, then you'll see that we end up with all of these additional main.dart files. And just to show you the difference in size, most of them will still have to be loaded in initially, but this is because it's a quite simple application. The moment your features tend to grow, the weight of this will definitely move to the different parts. But as you can see also, they differ a lot in size. This last one, for example, contains all of the localizations for the Wondrous app specifically. The other ones didn't have that many labels or resources, so they remain quite small. Okay, and with that, I want to come to some closing tips and common pitfalls that I noticed along this path. Starting with event propagation. So you may have noticed it, but what actually happened is that the events that happen within the area of our Flutter view still make it into the web application. In this case, I'm taking advantage of that, and I'm letting the Flutter view move up with the hover. So all pointer events, whether it's tabs or hovers or whatever, they're not specifically caught. It remains the responsibility of the host app to deal with that. So it could be used to your advantage, but it could also, it could happen that some unexpected behavior might occur. Another thing about the host elements that I want to point at is that all the children that are initially within the host element will be deleted once the Flutter view starts. As you can see, initially we have like this span and this paragraph, and afterwards we'll have the Flutter view and some other children in there, as well as new properties that were added to our initial host element. So this could come with some weird behaviors as well, so be aware of that. One more thing is about the URL strategy. So by default, Flutter web apps follow the hash URL strategy, which will interact with the browser history and the URL that we see in the browser. This can cause also some weird behavior, definitely if you're running in a single page application that listens to that as well, and they can conflict. Now, mostly for embedding apps or embedding Flutter apps, and definitely for multi-view embedded apps, this is generally not needed. The simplest solution there could be to simply set it to null, and you have to introduce this before you call run widget. If you want to rely on that behavior, you can also implement a different URL strategy and provide it there as well. Two more things. Be aware that this our embedded Flutter app uses CanvasKit and not the regular HTML elements. And for tools such as session replay, which can be offered by, I think Sentry has it, Datadog has it in this example, what you see is that first we're in a normal application and suddenly most of it is gone. And this is the part where our Flutter view is introduced, but it remains a black box to our telemetry. What I could suggest here is to use JS Interop to forward those events to your telemetry, or you could just completely implement it within the embedded Flutter application. And to close off, one thing I just want to say is use this with caution. Don't overuse this embedding. I would suggest in general, like, use it for isolated features mostly, and try to provide a clear interface between the JavaScript part and the Flutter part, because the chances are that both the host app as well as and the Flutter app will be managed by different people, by different teams, maybe not now, but maybe in the future. And I don't think that the web team will like their Flutter developers as much if we make their life hard. So be kind to your fellow developer. With that, this is all I have. I would ask you to scan this QR code. This will bring you to a small feedback form where at the bottom it will give you all the links to the slides, to the to the demo application, as well as some other interesting documentation. And let's connect as well. Yes.
Yes, I just have a question about the bootstrap managing and like the styling of the HTML elements itself. Because one of the first slides I saw that you are doing inline styling on one of the, like, I think it was a heading or something.
Yeah.
Do you usually depend only on the bootstrap, or for example, if we would like to use it, is this inline styling dependent, or we are like supposed to separate it normally as a separate CSS file, or how do you just manage it?
You can choose whatever you like. Let me try to get to those slides quite fast. It should be here, this one, I think. All right. So I just use this as an example. This is actually all depending on your host application. So whatever they use, if they use, I don't know, like Tailwind, or they use React applications, they use Vue, they organize their styling for these elements differently. It doesn't matter. I just put it in line to make the example clear. What I didn't actually mention, but what could be interesting, is that was step 4 somewhere. Was it this one here? So with add view, we have to add the host element. We can add initial data, but we can also add view constraints. So by default, the Flutter view that is added will take up the whole space of the provided element, of the provided host element. But if you want that to be smaller or constrained in a different way, you can provide constraints there as well. Yes?
So you can pass some values to Dart. Can you do the other way around? Can Dart pass some values to JavaScript?
Yeah, this is all done with JS interop. I didn't go into that on this talk because it tends to grow to a separate subject completely. Yes?
How difficult was it, because you started off with, we have a mobile application.
Yep.
How difficult was it to extract those components and put them in the web?
So it wasn't too hard because of one simple reason, and that is going back to the whole initial, a lot of slides. Okay, this one. I just wanted to show that we actually just, we started with one application, and then before we put it into the other, also mobile application, we extracted a package out of that, and that was most of the work already. Once that is done, there are a few concerns that you have to be aware of, and that's you're running on web and not on mobile anymore. So some things will be different. Depending on your architecture, that could be a walk in the park, or it could be a roller coaster ride. You choose. Yes, Chris.
I played with it also a week ago or 2 weeks ago, and I started with a demo app I found on the internet, and that was called CRA Flutter, and that was actually a web React application.
Yeah.
And there they also added JS interop with communication from one to in both directions.
Yes.
And I also I did further on it, and I was able to use WASM also.
Oh yeah.
It's also possible to.
Yeah, I used WASM as well. I didn't include it in here. I just wanted to keep it as simple as possible. The only thing that I needed to change after adding WASM was about the JS interop. So if you see, we created this properties object. I don't know how it was exactly anymore, but you couldn't just easily cast a string, because like for JS string to a Dart string, it just works. For a JS string to a WASM string, something was blocking.
I also had some problems with doing a promise in React, and that was converted to an await, but only in JavaScript. And then on WASM, I had to do another magical conversion in Flutter, and after I found that it worked, so you can just do a promise in JavaScript and wait for the result.
All right. Cool.
There's a question from Jens, who's watching the live stream. So indeed, you talk about sharing state between different views, but how is the state actually shared? Is it just the memory, or how does it actually work?
I'll show that in the demo application. It's very simple. We have simply we added in our widget tree above our multi-view app. So the only thing that we need to make sure is that the first widget that needs to render has to be of the type of view or view collection. And this is managed by our multi-view app. All the rest, we can put any type of provider or any type of other types of widgets above that, as long as the first widget that will be rendered will be a view.
I think the view part is actually adding some stuff like media query and so on to know how big the screen is, because if you forget that, your app will crash and say media query is not found or something like that.
Yeah, exactly.
And I have a question as well.
Okay.
I ran into issues on web where reloading your latest main.dart file sometimes takes a while because of caching issues.
Yeah.
How do you currently solve that? Is that also an issue with the multi-view, or is that just similar across?
So I had the issue before, and after enabling hot reload, I didn't run into that issue anymore.
But not in production, maybe. In a hosted.
Oh yeah, okay. So I think in general, I think it's a service worker that takes care of the caching. So you get a default service worker with a Flutter web app. In this example, I just skipped it completely. That helps. But I think I can imagine there's that's where the issue lies. Yeah. Anybody else? All right.
Okay.
Thank you.
Thanks a lot.